In these problems, we're being asked to do something called evaluate functions. And in case you haven't seen this f of x notation before, this is the name of a function. You might be more familiar with seeing just the letter y over here. In the equation of a line, you'd have y on the left maybe and the rest of it on the right. You can think of f of x like y, except it's sort of a different name for this function. And the way the notation works is that whatever value you put in place of x here, so we're being asked to find f of 2, that means in this chunk right here, which is the actual function, you substitute in that value in place of x wherever you see it, and then calculate the result. So let me show you how that works. F of 2 in this case is, well, we'll copy out this function, just replacing x with 2. So first I have a negative 2, and then I have my x. I'm going to put the 2 in parentheses there, and then that x gets squared. So I've got to square that 2. So all I've done is put in 2 in place of that x right there. Next we've got a negative 3 times x, so I've got to put a 2 in there, and then we have a plus 2. So there's the whole function with x in those, with 2 in those two places instead of x. Now we calculate. So 2 squared is 4 times a negative 2, that's a negative 8. And then we have a negative 3 times 2, that's negative 6. And then we have a plus 2, that is negative 12. So f of 2 equals negative 12. Let's try another. This one is a little trickier. Here we have our function, f of x, that's the name of the function. Here's the actual function, it's x squared minus 6x. And they're asking us to find f of d plus 5. So you can put in more than just numbers here. If you put in a number, you could easily calculate this in this function, but they're giving us this expression, d plus 5. We're just going to go about it the exact same way we did above. It's just going to look slightly more complicated. So we're finding f of d plus 5. And so I need to put d plus 5 in wherever I see x in the function. So first I have x squared. That means I have d plus 5 squared. And then I have minus 6 times x, so that's minus 6 times d plus 5. Now I should probably multiply out this d plus 5 squared. So when you square something, you multiply it by itself. So this is d plus 5 times d plus 5. We should go ahead and FOIL that out. So the first term is d times d, d squared. The outside terms, d times 5 is 5d. Inside terms, 5 times d is 5d. And the last terms, 5 times 5 is 25. Okay, so that's FOILed out. And then we should also distribute this negative 6. So negative 6 times d is minus 6d. Negative 6 times 5 is minus 30. And let's see if we can combine the like terms. We only have 1d squared, so that stays. Then we have a 5d, and a negative 6d. So that's 10d minus 6d. That's 4d total. And then we have 25, a plus 25, and a negative 30. That adds up to a minus 5. So f of d plus 5 is, is d squared plus 4d minus 5. All right, we're going to try one more. So functions don't have to be named f. You can call them anything you want to. In this case, this function is called h. So the function h is this chunk right here. H of x is x squared plus x plus 7. And we will want to find h of b squared. So what that means is you're going to put in b squared in place of x. So our first thing we have is x squared. So we put in b squared for x, but then we have to square it because x is squared. So that's b squared squared. Then we have plus x, so that's going to be plus b squared, and then plus 7. And the only little bit of simplification we need to do here is take this power to a power. When you take a power to a power, you multiply the exponent. So this is 2 times 2, or 4. So that's b to the 4th. And we have our plus b squared and plus 7. So that's a little bit of work with evaluating functions.